Hey everyone, welcome to this next Cloud Lunch and Learn Marathon session where I'm going to talk about Azure DevOps pipelines and allowing you to enable Cloud Magic. This event would not be possible without our sponsors and the Cloud Lunch and Learn supporting team. So first of all, thank you to Microsoft and Redgate for their support, as well as you here in my audience. I would say, obviously it is all fine to create content, to create a conference, but if you don't have any attendees, it's not really worth the trouble. So thank you first of all for being here. I hope you're going to enjoy the next 60 minutes and learning about Azure DevOps. Besides you as the audience, besides the sponsors, also a nice word of thanks to our collaborative friends from the C# Corner, .NET Mafia, the Dublin Azure Meetup, and Cloud Family. If you want to follow along, if you want to create some buzz online, feel free to use Twitter for that, where you can include the hashtags CLLMarathon, as well as the @CloudLunchLearn tweet handle. And if you want to include my own one, that would be PDTIT. Now, what I'm going to try and cover in the next 60 minutes will only scratch the surface of some of the core capabilities of Azure DevOps. Now, what it means to scratch the surface, is it going to be introductory? Maybe for some of you, although I guess that you're all a little bit familiar with Azure DevOps, or at least the concept of pipelines. So I'm going to speed up a little bit there and switching to quite some demos, literally showing you during some live demos what it looks like. Now, in short, what I'm going to cover is starting from the basics, meaning source control. What is source control? It's allowing you a mechanism that allows you to efficiently store application source code and maybe even infrastructure deployment templates in an efficient and collaborative way. From there, we're going to reuse our source control and integrating it with project management. You might think about well, it's DevOps. That's already a project methodology by itself, but technically it's more relying on scenarios like Agile, Scrum, although you don't really have to use those. Now, out of project management, it's going to allow you to follow up, who's working on what, and maybe defining deadlines that we would call sprints in a DevOps terminology. From there, we're going to use build and release, where the build stage is also described as source validation, meaning you're going to compile the source code, validating, maybe integrating some functional testing to find out if everything is working as it should be. And then last, that's where the real magic comes in, I would say. You're going to run your deployments, which could mean moving into a dev and test environment, production environment, staging environment. I'm going to use Azure as a target, but note that Azure DevOps, although it has Azure in the name, allows you to target any language and any target environment. Now, before jumping in DevOps and using Azure DevOps as the tooling to enable that magic, let me just share some session scenarios. One example as an infrastructure backend, I would say, out of my own background. You might have a collection of ARM templates that you've been using for a couple of weeks, maybe months, maybe a couple of years already, and allowing you to deploy end-to-end infrastructure. An example I'll use is web VMs and SQL database VMs. Or you might have a web application that you want to push into Azure Web Apps. Or you have a web application that you want to containerize. By the way, I have another session here during Cloud Lunch and Learn that's talking about Azure Container Services. So that might be a good one to check back on, although I'm not really using DevOps there. Maybe overall another scenario where it would be nice if you could deploy almost everything at once. But next to that, it's not just about deploying. You might have managers wanting to approve your deployments before pushing them out, and maybe allowing you to switch across different backend environments, dev and test, staging, production, or overall maybe not even deploying anything, but just running validations based on conditions and the overall health state in Azure, which could mean that a deployment could fail because some service in Azure or maybe an Azure region is not available at that moment in time. And so many other scenarios. Again, I'll talk about DevOps magic, and hopefully by the end of the session, you're gonna agree with me. So in short, my name is Peter, Peter D. Tender, based out of Belgium, and currently working for Microsoft as an Azure technical trainer. What we do is providing Azure training to larger customers and partners all over the world, where I'm mainly touching on the EMEA time zone. I've been active in Azure for about 10 years. Before that, I was 100% focused on on-prem data center technologies using Microsoft as the core product, deploying physical components, Hyper-V, installing Windows servers, Exchange servers, and everything that comes with it. Was an Azure MVP for 5 years before I joined Microsoft, and in the little bit of free time that I have, you can still find some online content out of myself by writing technical blogs, technical books, and overall helping other ones to publish more content. Feel free to stay in touch. I'm pretty active on Twitter, I would say. It's my starting point for even following up what's happening in the technical world, but also active, not always that active, depending a bit on availability and time constraints, but I try to at least write one blog post every couple of weeks, and you could find that information on 007ffflearning.com. So with that, let's jump in. So I'll start with explaining what DevOps stands for. Now, there's a lot of different definitions you could use to describe DevOps, but in short, it starts from a planning phase where you're going to think about, this is the workload that we have, this is the language developers are going to use, and from there you're going to start building it. That's where you start developing, maybe as an infrastructure guy or girl, you're going to try to build your environment in a proof of concept, already making it ready for production or a dev and test scenario. Once you have your source code enabled, you're going to validate it, verifying it, like is this actually running, integrating maybe functional testing, user testing, and eventually you're going to package it. Think of like a web deploy artifact that's allowing you to publish, release as we call it, your application. Once it's running in any of the staging or development or production environments, you might still change some configuration options, integrating monitoring, and based on the feedback from the platform, maybe based on feedback from users or overall customer base, you go back to the planning stage and repeating the same process over and over, a continuous motion. So one of our DevOps experts within Microsoft came up with his own definition, Donovan Brown. He explained DevOps as being the union of people, processes, and products to enable continuous delivery of value to your end users. And it's valid for any kind of organization. Delivering value means helping the business. This could be by releasing software. This could be by deploying an e-commerce platform. This could be by optimizing healthcare systems or anything else, right? Manufacturing. So DevOps is not only for cloud applications. It's not only for specific organizations. It's literally valid for anyone who wants to use it and optimizing the software lifecycle, as I would describe it. Now, I came up with my own definition, not just for the fun of it. I mean, I'm delivering quite a lot of Azure DevOps training out of that Azure Technical Trainer position, and out of feedback from attendees, customers, and partners, I somehow came up with a slightly different notion to that DevOps definition that we already had. I describe it as an integration of culture, and that's quite important, where you're going to interact with different teams within your organization, but also outside of your organization, to obviously still deliver value to the end user, relying on team collaboration and workload automation. So the keywords are integrating culture and focusing on tooling, where DevOps, again, although we do have a product called Azure DevOps, but it's not about Azure DevOps as such. The concept is there, the methodology is there, and it doesn't also mean that you need to start like from scratch and redoing everything. It's really that continuous motion. If you want to start with the source code you already have, but maybe you're not using source control yet, that could be a first good step. Or maybe you already have source code in the source control system, but you forgot to validate it, to test it, where now you might be interested in learning about some of those concepts. Or maybe why not using Azure DevOps to target different environments, where again, it's not just focused on Azure. So with that, let's jump in the next part and talking a bit about Azure DevOps itself. So Azure DevOps is a suite of products, like different capabilities in one single product, allowing any organization to do better DevOps. So literally what I talked about in this previous slide, that continuous motion from planning, building, all the way to release, monitoring and back, and having that continuous motion going on, that's literally what Azure DevOps allows you to do. Within Azure DevOps, you have a couple of different scenarios. So you start with Azure Boards. That's the technology you would use for project management. We talk about work items, we talk about work item queries, we talk about sprints, and I'll try to show you a little bit of that later on. The biggest part I would say out of Azure DevOps would be the pipeline engine, but it should already be clear it's not just the only option you have. Azure Pipelines allows you to build CI/CD, continuous integration, continuous deployment, pipelines, targeting any language, any target platform, on-prem environments, cloud-based environments. It doesn't matter. The other nice thing is that source code can live in Azure repos. That's our source control system based on Git. But if you don't like to use those tools, or you already have tools from other platform environments, Azure DevOps is a perfect target to integrate with those as well. You might have heard about Jira, you might have heard about Jenkins, TeamCity, and a lot of other DevOps tools. And there's a perfect integration possible where you might go like, well, we're going to continue using Jira for project management, but we're going to rely on Azure repos or Azure pipelines out of Azure DevOps. Or maybe you use Git and GitHub as another example for source control, where you're not even using Azure repos. And that's perfectly fine. You can use boards, pipelines, and some of the other components and skipping Azure repos. So quite a lot of flexibility there. The other two scenarios we have is Azure Test Plans, allowing you to test and ship your applications. And Azure Artifacts is like a centralized package manager. If you have Python, NPM packages, .NET packages out of NuGet, Java packages with Maven, you could centralize those, where the benefit is that instead of giving that responsibility to each and every developer out of your DevOps team, you could now publish it as a centralized artifact repository. So the starting point will be source control. What is source control? It's where you're going to rely on Azure DevOps repos. And again, just an option. You don't really have to use it. We integrate with a lot of other ones as well. And Azure DevOps repos by itself is a Git compatible source control system. You might have heard about Git. Maybe you use Git without actually knowing it out of GitHub from the portal, and that's perfectly fine. The benefit is that everything that's like part of the little piece of magic of Git is completely integrated in Azure DevOps, which also means that if you're using Git today or any Git compatible scenario, you can easily migrate and move into Azure DevOps repos. If you use GitLab, Bitbucket, GitHub already mentioned a couple of other examples, it's perfectly fine to integrate as well and not using source control out of Azure repos. Everything you know from Git, committing changes, branching, pull requests, all those options are available within our source control. So with that, let me switch to my DevOps organization. If you are wondering like how to get started with Azure DevOps, I could actually show you. So you would start from the Azure portal, where you can search for DevOps. And it's going to show you two different capabilities or two different service options. The first one is DevOps Starter. I would say that's like a somehow, almost hidden capability where you can deploy a web app, you can deploy a database service, but mainly web apps, I would say, where you're going to integrate the end-to-end DevOps concept to publish an application, no matter what language it's using, where we're going to try and integrate with Azure DevOps, but you're not really using Azure DevOps yet. Another option that's obviously what I'm going to recommend is using the full Azure DevOps organizations. Now, what you're doing with DevOps organizations is literally creating like a boundary for your company, for your organization, in which you're going to create a project. You could start with one single organization and one project, or one organization and multiple projects. From a management perspective, like who can use Azure DevOps, it would mainly be based on your Azure Active Directory group membership. So from here, if it's the first time, you're going to start with My Azure DevOps Organizations. It's going to walk you through a small wizard asking for an organizational name, the region where you want to store that information, and you're good to go. From there, you end up here in the Azure DevOps environment, and maybe starting with a couple of basic integrations related to your overall organization. So your organization needs a unique name. That's how you're going to identify who you are and what you're going to use. And the landing page would be dev.azure.com/ the name of your organization. In my case, PE Tender for obvious reasons. There is a billing component as well. And the billing mainly refers to running compute. Because what you do with Azure DevOps is running pipelines, right? Running pipelines out of the build stage, the release stage, and you could also use it for project management out of the work items. And obviously there is some cost attached to it. So one of the first steps that you might jump into is defining billing, where the billing is linked to the amount of compute minutes you're going to use for running pipelines, or if your organization has a Visual Studio plan, they might already use DevOps and you don't have to provide billing up here. There's a split up in cost, but don't want to talk too much about it, where you can see a difference in the compute cost for running the pipelines or the cost for end-to-end user licensing, like how many of my project team members are using Azure DevOps, although maybe only 1 or 2 of them are actually running pipelines. So pretty nice combination there. Within the organization, you're going to define projects. Now, I do have a couple of them that I'll switch through around in a couple of my demos, but look at a project as a standalone environment where you're going to enable everything, use everything related to that project. So you can create one project for work items and not using pipelines, for example, or what I've typically been doing is using all Azure DevOps capabilities for all my projects. Now, every project is literally a somehow standalone isolated environment. So it means that you need to define your project team, you need to define who can do what, and building up your membership. So let me start with source control. That was the first part I talked about. So we're going to zoom in here on Azure repos. Now, this is an existing project, and I already have my application source code in there. And obviously the question is like, where do you get started? So what you can do is creating your empty repos. You could create multiple ones. So this one only has one of them. I'll show you later on in another project how easy it is to create new repositories. So you could end up with a scenario where you have a repository for application source code, another one for sysadmin artifacts like ARM templates, PowerShell scripts, CLI scripts, and maybe even splitting it up based on the application source code you have. From there, we're going to clone into any possible popular development environment. So it's not just integrating with Visual Studio, not just integrating with VS Code. If your development environment is not showing up in this list, don't worry too much about it. Again, as long as it's Git compatible, you could still use Git command line as a way out. So I'm going to use VS Code because it's pretty lightweight and easy to do some demos. Well, now it's going to ask me to open this up in my VS Code environment. And I first need, let me just move this up a little bit. That's the challenge of having multiple screens. For some reason you cannot really see it, but what I am doing right now, I'll just talk you through, is creating a new local folder on my local machine. And since we're talking about parts unlimited, I'm going to call this the PU live demo. So what it's doing right now is cloning the existing Git repository. And again, there was already source code. This could be like one of the steps you need to go through when you're joining a team or when you're collaborating on a new project. And it's copying everything from the online Azure DevOps source control system and literally cloning it into the backend. Again, this could be command line based as long as you do have the access credentials, the URL to connect to the Git compatible repo, you're good to go. While this is running, let me switch back to the PowerPoint and share a little bit more about other source control capabilities. Where technically I don't really need my PowerPoint, right? So what we did is in the backend, it's copying everything from my online source into my local machine. From there, I could make changes. I could work with commits. So let me briefly touch on that one. So since the history of the project, if I go all the way down, this project has been around for quite a while already. And again, obviously it's about Azure DevOps. It's not a Git Git session, so I can't really touch on a lot of details, but if you're a little bit into Git, you probably recognize all this, where you have your project team, all the teams are collaborating and checking in code. That's what we call commits. Based on that, we're gonna run pipelines in the next topic. But what we can do here is creating like a local branch where, for example, we might have a local copy on my local machine that I call the PDT DevOps branch. So this would be my personal copy on my local machine where I'm working and making changes to already existing source code or adding new capabilities. From there, I'm gonna commit my changes and using a pull request to do that. Again, there's a lot of content available on how to integrate Git with overall Git commands or VS Code extensions for Git. So I'm not going to spend too much time. It's more about Azure DevOps having a full Git compatible repository in place. Good. Once we have our source code in place, and technically you could actually do the other way around, where you're going to start with integrating your DevOps boards. If you're using a new project, you need to identify what kind of project method you want to follow. Is it Scrum-based, Agile-based, or if you're not using any of those, you could also go for basic project management. Any project member already mentioned can be an Azure AD member from your organization or any guest user that you can invite by email. The nerve center, the core capability of DevOps boards is creating work items and identifying sprints, like what is the follow-up, the deadlines our team needs to work on, and if something cannot be completed within a specific sprint, we're gonna move it into a backlog. And let me briefly switch back. Let's see how far VS Code is. So it is completely synchronized to my local machine. And cleaning up my code environment a little bit, where I'm gonna see my parts and limited changes. So let me briefly touch on my previous scenario. And for example, making some changes to my source code. I'm just grabbing any files not that important for now, and maybe adding a little comment. It's a little slightly different syntax here. That's what's happening when you're using different development languages, right? Where I'm just gonna update, like Peter was updating this in the live demo and saving my changes. What it does here is integrating with source control, and it's immediately identifying like, oh, way cool, you have a changed file. And if you select that file, it's literally gonna highlight what has been changed or what has been removed. Next, we're gonna switch to commit, and the commit could be, I don't know, updates by Peter, and we're gonna check it in. Now there's a little safety net in VS Code, like in most other development environments, where the commit has been confirmed. You can see right now that the change is somehow flagged as okay, but it's not visible in Azure DevOps yet. If I go back to my files, you're gonna see that nothing really changed. Why not? Because we need to run this little synchronize, there's my mouse, little synchronize from here, which means we're gonna push our updates from my local machine into, and this time it's going through. So I could follow up in my commits, finding out like what's actually happening, and they're green, so way cool, fine. So let me move on and talk about boards a little bit. So what we can do here is integrating our work items. What is a work item? It's literally anything that your team is working on. Just a couple of examples here. So I'm creating to-do tasks, I'm creating follow-up projects, and anything else you want. For each and every of these, you can provide a description, you can provide a status, like what's the ongoing aspect of my environment. Who's the responsible? So Peter is working, it's already committed, and it belongs to this project. Remember I talked about source control. So what we can do here on the site is building up a link between source control changes and work items, which means that the project management is end-to-end covered. If there's a new commit happening, if there's a pull request coming in, I can easily integrate those two worlds together. Way cool. This brings me to pipelines, probably one of the more relevant components, I would say, to really enable cloud magic, although everything I talked about up till now is actually pretty valid as well. So code validation, or the pre-flight status, is the build stage in Azure DevOps. It allows you to compile your application running on-prem, running as the compiled state on-prem, or using the pre-built Azure DevOps build agents, as we call them, virtual machines running on Azure, depending on a Windows operating system, 16 or 19, Ubuntu Linux, or macOS. And again, that's why we can support any language, any platform. From here, you could extend them with additional step-by-step tasks. You can make them a lot more powerful by integrating functional testing, user testing, integrating code scanning, but I'll talk about that a little bit later on. So a couple of options. What you're going to see, and I'll try to show you, what you can do is using the classic pipelines, where you're going to rely on a graphical interface, allowing you to select tasks. Like in the screenshot here, we have a .NET application, my Parts Unlimited application that I'm using as a reference. And we're going to start with installing NuGet, the package manager for .NET, on the build agent, running the NuGet restore, running a build scenario, integrating some testing, and eventually producing like a web package that can be used to publish my artifact. If you're maybe a little bit familiar with like GitHub, and maybe GitHub Actions, it's another pipeline tooling, you might be familiar with YAML. YAML is a text-based DevOps as code, is an I would say an alternate methodology where you're going to see that it's not using anything from the classic interface, but it's all text-based. The advantage is that all the YAML files, like your DevOps as code source files, are immediately stored in Azure repos and giving you the benefit of using source control, what I briefly touched on before, to also manage any updates in your YAML environment. The nice thing is where we're trying to offer you the best of both worlds, I would say. If you have a whole bunch of pipelines created years ago in Classic, you can somehow migrate them or easily migrating, depending a bit on how complex the pipeline is, and literally mixing the two together. Or you can still rely on the graphical interface to find like a corresponding snippet, but not using Classic anymore. So that let me go back to my pipeline environment. We're now in Azure DevOps. We go for pipelines. I already have a couple of them just to explain some of the scenarios. So let me start with one of the first ones. Maybe before opening the details, so what you can see here is that there is a nice integration between the build pipelines, like compiling the application, and your commits. So whenever anything was changing in source control, out of a commit, a couple of days after a new commit, a couple of hours after a new commit, whenever we're touching the master branch, or maybe even other branches, which by the way should now be rebranded to main branch because it has some connotation there, but this was a pretty old project I imported as a reference, and that's why it's still showing up as master. Looking into the details of the pipeline, it's literally showing you step-by-step scenarios. So pretty much what I already explained out of that screenshot is shown here. So it is starting with .NET because it's a .NET package. It's starting with NuGet, where we're gonna tell the platform, I want you to run a NuGet task. We're gonna build a solution integrating testing and eventually copying files. Now, if you want to add some new capabilities, you can just add a new phase and searching for what you want to do. So if this is a .NET Core based example, we can add a little step in here. You could move it around and using the commands here to maybe replace that graphical build option out of VS Build and replacing it with .NET Core, just an example. If you want to migrate this existing pipeline, or you start from Classic, and you want to migrate into YAML, you can do that from here. So for each and every task that we have in the classic interface, it's allowing you to migrate to YAML as well. The other option is the YAML-based pipeline. And let me create a pipeline from scratch, where I can show you a little bit more of how all the other components are nicely working together. So the first step is, let me make it a little bit bigger, there we go. So the first question is like, where can I find your source code? So again, it can be Azure repos, but it doesn't need to be. It also supports any of the other platforms. Selecting the repository, and based on that, it's going to provide us a couple of options, like this is what I want you to do. If it's .NET, that's fine. If it's Xamarin app or anything else, it's just trying to help you. If you already have a YAML pipeline from maybe another platform, or maybe from running some testing or just out of another project, you could export it, importing it, and it's going to work perfectly fine. So this was a .NET application. And what it's going to do here is automatically creating a nice YAML pipeline, where technically it's still doing the same thing. Whenever something is changing in my source code, we're going to use our Windows build agents. We can define some variables, and from there we're going to run through a couple of steps where we're going to identify the different tasks we have. This is the task to install and run, at least install, and down here run NuGet. From there we run a task vs build, picking up some of the variables we defined, and lastly running some testing. If you want to add similar tasks as what I showed you before, you got this little gimmick here on the side, injecting classic based tasks, where let's say we again want to copy some files. We could now nicely complete it from here, where my source folder would be my build directory variable, everything that's in there. The target folder would be my artifact folder, or anything else. I mean, it's just defining some variables, saving it, and what this will do is injecting that little, probably made a typo somewhere. Oh, I don't have permissions. But that also makes sense. Little demo to show you how the permissions are actually working. So I can use the project, but I cannot create new pipelines. That's literally what it means. If I wanted to make updates, I need to go through the branching updates and integrating with pull requests, but not gonna do that. Mainly wanted to show you like how to switch from Classic to YAML and still relying on Classic to actually go from there. Once we have our pipeline in place, it's allowing us to compile our software. So let me go back to the sample pipeline that I had, and we're gonna run this again. So running it means that we're gonna compile our application, which could integrate functional testing, user testing. If you run PowerShell script, Terraform scripts, or anything else, you could still run or rely on like a PowerShell lint tool, or Terraform lint to validate template syntax. Those kind of scenarios are technically still the same. And you can choose the agent pool, where again the pool can be a collection of on-prem running servers or cloud-based running servers but running as a private environment, or the default behavior integrating with Azure pipelines, which means that you're going to use Azure running VMs that you don't need to manage, you don't need to build, and we're just going to compile our application. From here we get a pretty detailed view on what's happening. So it starts running, we can see the repo, we can see the branching, and eventually when everything is complete, we're gonna get one artifact. For each and every stage, it's gonna show us the details of the process. So it's gonna start with initializing the files, checking if anything is fine or wrong, reaching out to the repository, cloning the files to the build server, and from there, it's already running my NuGet restore. It should be clear that you do get a pretty detailed view if you're running PowerShell tasks, if you're running CLI tasks or anything else. As long as it is producing console-based information, you can get it up here in your scenario. Now, as you can see here, something is wrong with my build, and we need to identify like what's wrong. Most probably it's because I'm probably not using the correct backend for this project, where it's relying on Visual Studio version 15. I selected the build server 19, so it's probably a little bit out of versioning. So I need to go back, or I could switch. Maybe it's a .NET Core application where I'm not going to compile it on a Windows platform, but I want to compile it on a Linux platform, maybe macOS, but that would be pretty straightforward. There's a lot more you can do with build tasks, but I'll try to come back on that later on. So once we have our build, a successful compiled piece of software, we can move into a release pipeline. Now the release pipeline is again moving to a running state where we're going to target our target environment. Can be Azure, can be on-prem, Hyper-V, VMware, virtual machines, can be AWS, Google Cloud, or literally anywhere else on the planet. Easy deployment, I would say. You can move across different environments. So you could have one single release pipeline interacting with dev and test, from there moving it into production, or maybe in between Q&A or anything else, as well as integrating with deployment variables. So within the pipeline section, we have releases. And within a release, we can build up like what we want to target. I got a couple of scenarios here. Don't worry too much about the failed state. It's because I actually don't have the actual backend environment up and running. But I'm going to try and show you like what it looks like. So I have my artifact. That's the endpoint of the build stage, which, by the way, there's a property setting. I might switch back to that later on if I remember. There's a little property setting allowing you for continuous integration, which means that whenever something's changing in source control, the commit happened, the pull request branching interaction happened, it's automatically building up a new version of the artifact. So the artifact will always be the starting point, and from there we're going to deploy, run to different stages. I got one dev stage, I got a production stage, and for each and every of the stages, we identify the actual steps that we want to go through. In this example, it's a web app. It's already pre-baked. It's compiled out of the build stage. And the only thing we need to do is moving it into, in this example, an Azure web app. What we need to do for that is, again, selecting any of the tasks from the task list. There's a lot of options. There's more than a couple of hundred sample tasks that you can go through, from mobile application testing, as you can see here with Android, all the way to running container, Docker, Kubernetes integration, and anything you could rely on from your own environment. In my scenario here, I'm targeting the Azure platform. So what I need to do is building my Azure platform. I'll try to show you later on how you can mix and combine different steps together, like building the infrastructure and publishing code. But what we need is an Azure integration. An Azure integration, or any target platform integration, is done from service connections. What is a service connection? It's where you're going to integrate a service principal or managed identity for Azure, basically providing credentials that you can use to communicate out of Azure DevOps with your backend scenario. Out of your project settings, quite important, the service integration, service connection is defined on project. So it means if you got multiple projects, you need to go through this process a couple of times. So what I would need to do here is defining my service connection for a lot of different target platforms. I'm using Azure, so let's select Azure Resource Manager, and I need to provide service principal details. If you don't really know what a service principal is, actually pretty good news. I have a little bit more in-depth demo where I'm going to reuse my Azure DevOps environment out here on Cloud Lunch and Learn, talking about service principals, managed identities, overall what is the concept, and just using DevOps as one of the so many examples. but it's literally providing authority, authentication, credentials, providing like, hey, pipeline, if you're running and you're communicating with Azure, I want you to use these credentials. So let me switch back to my environment. So I'm using my Microsoft subscription, and I'm going to target the Dev Parts Unlimited target environment. I can go back to my pipeline and validating the same in a production environment. Now the only difference is that my web app target will be different between dev and test, my previous Parts Unlimited example, and my app service name here, which would be a different web app in the Azure platform. Showing you some other capabilities, let me switch to another project where I'm mixing Azure CLI, I'm mixing PowerShell. So it's not just about pre-deploying your infrastructure upfront, like what an ops team would do, and then adding the application publishing, what a developer would do. It's literally combining the two worlds together. So for example, what we're doing here is deploying some infrastructure as code, where the starting point is the exact same as what I showed you in the previous project. We have our compiled application, and within, I'm running different stages. So I'm going to run some Azure CLI in this example, where you can choose injecting a shell script file or literally using inline script. What I'm doing here is literally CLI scripts. So think back about my first couple of slides. Integrating DevOps means reusing what you have, collaboration across different teams, and this could be moving a snippet of code that you already have out of the ops team into a friendly DevOps pipeline. Next, we're going to copy files similar to the task I showed you earlier in the build, integrating with some PowerShell for whatever reason, just as an example, and eventually we're going to run a final task that's running an ARM template deployment. This ARM template is defined down here, and the artifact is coming from my repos. So what I'm doing here is storing different repos linked to the same project. I got a web front end up here, I got my development cycle, and I got my ARM templates. If I switch to ARM repo, that's where I'm collecting all my ARM templates. So these are coming from my ops team, nothing's really changing in the process, and we're just gonna make it DevOps friendly. That's what it means. From here, I could do the same, selecting any of my pipelines, running a release where now it's going to target my Azure platform. With the exact same details that what I showed you in the build stage, asking you what kind of project you want to use, and eventually pushing the button, and it's going to run a new deployment. So while this is running, let's give it about a minute or so. It's moved into a queuing state, which means that after typically about a minute in my environment, it's going to start rolling, and from there we have end-to-end integration capabilities. Now what we can do once we have release is making it even more optimized. Now what does it mean more optimized? For example, you have pre and post approvals. Right now I'm just running my pipeline. I assume that the build stage is successful. Once the build is successful, we're going to move to release, and Peter is going to publish it, right? But remember, out of my sample scenarios at the beginning, it might be required that a senior developer or senior DevOps engineer is looking into it. Or maybe you're not allowed to publish anything out of Azure policies. Why would you push an ARM template deployment out of Azure DevOps to, I don't know, Azure Region West Europe, if you know there's a policy in Azure West Europe blocking you from deploying it? So you can extend your release optimization by integrating any of those, what we call quality gates. Or maybe you want to validate using REST APIs, you want to trigger an Azure function, or maybe interfering with Azure Monitor, like, hey, based on feedback I get from Azure Monitor, I'm going to allow or not allowing a deployment yet. Or last, query the work items. Remember, I talked about work items. You might come up with a scenario that If Peter has X amount of work items outstanding, or there's too many bugs getting reported, we're not allowing the pipeline to kick off. And so many other options. So let me briefly switch back where we can see that my pipeline is running. And I'm going to pick another release pipeline just for the demo, where I have a release gate that's validating monitoring integration. Now, the way it works is that you're going to go through your pipeline definition, similar to what I just showed you. And depending on your scenario, you're going to interact with an approval step here, or you're going to interact with a pre and post approval and quality gate scenario. So what we can do here is, for example, a pre-deployment validation, where now we're going to tell a quality gate definition that's going to define if the deployment can run in production or not. By the way, the approval that's up here, where you can define an individual list of users or maybe groups and defining how many of the group members actually need to approve the green light for actually kicking off that deployment. So that's another option. But I talked about gates, so just quickly showing you what it looks like. I have a Azure Monitor alert. So what I did is going into my Azure environment, configuring an alert, and whenever an alert comes up that fulfills my requirements here, so whenever there's an alert getting triggered in the last hour with severity 0, 1, 2, 3, and 4, so basically capturing any possible alert in my environment within this specific target resource group, which could be there's an outage with the storage account, the region is not available, or you just don't have any permissions to do so, or anything else, right? That would be the trigger for blocking my deployment. Once we kick it off, and I can show you the outcome of it, because it typically takes about 5 minutes to pre-validate, where next it's typically re-evaluating every 15 minutes. So if I go back to one of my completed tasks, you can see here that the starting point is pretty much the same. So when I kicked this up, it was checking Azure Monitor, there was an alert, so we're not going to approve it or allow it. 5 minutes after, we're still not allowing it. 5 minutes after, we're still not allowing it. And then obviously to have it back green, I removed all the alerts, like nothing's wrong with my environment anymore. And that's where we have the green light, which means my deployment was running successful. Or the interaction with Azure policies technically works about the same. So we have our scenario where in the pipeline definition, we're going to define Azure policy as a dependency in the quality gates. CLI, PowerShell, Azure Web App Publishing, so that's all pretty much the same. Where now from here, we go back in our quality gates pre-approval and selecting policy compliance. In this case, it means that whenever there's a policy violation and checking every couple of minutes, it's going to figure out if that's a green light or the red light, allowing or blocking the deployment. Interesting enough, you can combine any of these. So I could go back to my monitoring example, interacting with Azure policy, interacting with a REST API call, for example, targeting Azure or any other application supporting API, where you're going to validate like what's the API response code, could be like 200 or 404, and based on that, allowing the deployment or maybe blocking it. Really powerful features. I could talk about that for more than an hour just discussing release gates by itself. But slightly moving on, so a little recap up till now, got about 10-15 minutes left. So what we did with the DevOps concept is automating everything, which means we have our developer team, they're gonna run validation, they're gonna package it, eventually we're gonna run it, and once it is running, we're gonna operate it, monitor it, validating the health check. Perfectly fine. That's DevOps in 5 steps. But once it's running, it means that we're gonna automate everything. We have the developer, source code, work items, and everything I already talked about so far. But then there's a question about security. Maybe you heard about DevSecOps, like maybe, hopefully at least, Peter is going to talk about it. I promised you a bit of magic, so yes, we're going to talk a little bit about integrating or realizing DevSecOps by using Azure DevOps. Now what we're doing, and I might run out of time a little bit, so I'm going to speed it up. What we're doing in each and every of the DevOps stages is potentially interacting with security capabilities. Now in a traditional scenario, security focuses mainly in the running state, where we're going to validate firewall communication, making sure that there's no vulnerabilities in the application, there's no attacks happening like a DDoS attack or anything. But wouldn't it be cool that we could actually optimize it? Why? Because every now and then something goes wrong in our environment. We're running outdated packages. We're, I don't know, having little Swiss cheese holes in your application source code, I don't know, or maybe storing credentials in ARM templates, Terraform templates, or whatnot. So what we're going to do with DevSecOps is what we call shifting left. Shifting left means that we're going to integrate security in our DevOps process. We're not changing the process, we're just going to inject security capabilities. Obviously, where possible, as close to the source code as possible. Why, for example, this is what happened in my environment a couple of months ago, where I was using GitHub and storing personal access token, not really on purpose, but what actually happened was during one of my workshop deliveries, like pretty much this one, somebody who was watching it actually captured my security tokens. That's why, for example, I didn't go through the full demo on creating a service principal, because you're literally exposing secretly information. So I have this personal token in my environment, pretty secure, pretty solid. Somebody somehow got access to it and thought it was pretty fun to store it in GitHub. So this is not my GitHub where I'm storing the token. It's a token stolen, literally screen captured by somebody else who is watching my sessions. Now GitHub comes with a pre-baked in security, but maybe you're not using GitHub, and it means that we need to integrate another scenario. The easy scenario here is that there are so many tools available in the marketplace. It's like a online extension plugin capability for Visual Studio, VS Code, and also for Azure DevOps, allowing you to integrate, for example, security code scanning, code vulnerability scanning as part of your build or release process, where I would recommend to integrate it as part of your build process, where now you can do the exact same thing as what I showed you before, but integrating security code scanning. And it's not about the tooling, it's literally about giving you the capability, and it doesn't even matter what tool you're going to use. So back to my definition, it's where we're still going to do the same thing as before, collaborating, workload automation, implementing a culture, but what we're going to do is moving into even more culture, bringing more teams together, because now we're going to integrate the security teams. And out of that, because we're automating more and more, it is actually maybe going down to about 30% of your time and effort, still using the same tools. We're not changing anything, but we're going to switch to integrated security model. So got a couple of minutes left. So what I'm going to do is once more switching to my DevOps environment, where I'm going back to my Parts Unlimited project. By the way, if you're interested in playing around with Parts Unlimited, it's an open source Azure DevOps project that you can find on GitHub. So if you just do a little search for GitHub Parts Unlimited Azure DevOps, I'm pretty sure you're going to find it. So back to my build stage. Where we're going to integrate security code scanning. Now I showed you like a top 5 list. Since we do have our portal open, let me quickly show you what it looks like. So you go to the marketplace and you're interested in injecting security, where you can choose from about 80 different tools. Some of them are coming from Microsoft, some are coming from third-party vendors, some of them are a little bit more focused on specific workload scenarios. SNCC is a popular one. The overall Microsoft ADO security scanner is capable of detecting like code scanning, vulnerability settings like password, credentials, storage account keys from Azure. Aqua is a popular one in the container world, allowing you to scan containers and container baseline images for overall vulnerabilities, and so many other ones. I'm using Sonar Cloud, where Sonar Cloud allows you to recognize, again, code vulnerability, outdated packages. But again, it's more about the process, and it's not really, I would say, about the tooling itself. Back to my .NET pipeline, where we're going to reuse the same concept as before, but this time showing you what it means to integrate your security scanning. So we still have the same pipeline. We're running NuGet restore, building, testing integration, and eventually publishing files. Where now we're going to inject the task. I already told you how to inject the task. So what you need to do here is searching for Sonar Cloud, and it will show up once you have that integration from the marketplace. If you're looking for other tools, like White Source Vault is another popular one, or Snyk is another open source product. So a lot of them are available. I just picked one of them. There's no specific preference. But what it allows you to do is literally going through this pipeline build stage and at the same time scanning code. Sonar Cloud is publishing it in their own portal on sonarcloud.io. If you don't like to move your information into a public cloud scenario, you could switch to what I'm doing here, White Source Vault. It's about the same capability with a couple of other characteristics, like inspecting the packages you're using, and if you're using the correct open source licensing agreement, or any other tool that's technically doing the same thing. The outcome is that before you're going to move to release, because right now we're still in this build up my build artifact, and it's going to show you any potential issues. If your source is a container, just inject another container vulnerability marketplace extension, and it's going to provide you similar capabilities. So that's a little bit on DevSecOps, where again, the key message is move this all the way to the left, as close to the source control as possible. So with that, we're pretty much to the end of my session. They only gave me 60 minutes, although I could talk for about 60 hours about Azure DevOps. We're jumping back about 60 minutes in time. I started talking about DevOps concepts, that continuous motion, and from there touching on some of the core capabilities of Azure DevOps. Source control, Git compatible, source control supporting branching commits, pull requests, everything you might already know from Git command line, but now nicely integrated in Azure DevOps repos. Briefly touched on project management, where you can start creating work items, integrating to Kanban boards, moving into any possible project methodology that you look out for. Could be Scrum, could be Agile, maybe starting small with a basic one and interacting with sprints and backlogs, at least if you're using Agile or Scrum. From there, we move to source validation, where we mainly touched on the build pipelines, YAML-based, classic-based, and from there moving into release, running state of your application workloads, starting from classic tasks, YAML-based tasks, or integrating with different dev and test staging, Q&A, canary deployment, blue-green deployments. I mean, I hope that the scenarios were pretty clear, and luckily showed everything of that in some nicely working demos. So with that, I'm about finished. My time's up. So once more, where I started my session, thank you for being here. I hope you enjoyed it. Hope you learned from it. Feel free to shout out, create some buzz on the internet using Twitter, or send me an email, petender@microsoft.com. I hope you enjoyed it, and looking forward to see you again in any of my other online sessions. Have a great rest of the conference.